yesterday we were solving these quadratic equations and they all had nice pretty answers. Either they factored nicely with the box method or all it had was an x squared in it, so you could do your square root method and get x by itself. However, you guys know, you've looked at quadratics before, not everything has a nice pretty answer. And so we need different methods for solving those things that don't factor nicely. Completing the square is one method that we use. This method, some people really like it for quadratic equations and some do not. We need the method for some things that we're going to do later on with manipulating equations and rewriting them, so we're going to go ahead and learn it now and use it now so that we have it later on when we come to those things. First step in a quadratic equation, you need a coefficient of 1 on the x squared term for completing the square to work. So if you have any other number on your x squared, you're going to divide by it first. Second step, we're going to move the constant to a side by itself. So you'll have all the x terms on one side, the constant on the other. Then we are going to create a perfect square. So if you think about, when I say perfect squares, if I say x plus 2 squared, that means x plus 2 times x plus 2. And if you multiply it out, you get x squared plus 4x plus 4. Right? If I said x plus 3 squared, if you wrote it twice and multiplied it out, you get x squared plus 6x plus 9. If I said x plus 4 squared, write it twice, multiply it out, you get x squared plus 8x plus 16. Is there a relationship between this middle term and your constant? How are those numbers related?
They're divisible
They're,
by each other.
yeah, they're divisible by each other. In fact, if you took this number, 16, that's the same as if you did half of 8 squared, right? Because the 8 came from when you FOILed, you had a 4x and a 4x. So if you did 8 divided by 2, you get 4. 4 squared is 16. If you did 6 divided by 2, you get 3. 3 squared is 9. If I do 4 divided by 2, you get 2. 2 squared is 4. If I had x plus 5 squared, okay, 10 divided by 2 is 5, and 5 squared is 25. So do you guys see the relationship between that middle term and the constant? We are going to create a perfect square. So what we're going to do is take whatever coefficient is on our x, divide it by 2, and square it, so that we have a perfect square on each side. So we'll find that number, add it to each side of the equation, then we'll be able to factor and solve. So let's look at an example. Okay. First step, you have to have a coefficient of 1. Do we? Yeah. Second step is you move the constant to a side by itself. So I'm going to add my 14 over. I'm going to leave myself a little space here. Okay, we want to make this into a perfect square. So if we think about the pattern that we just saw, it's always half the middle term squared. So what you're going to do is take this number, we need half of it, so divide it by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So you add 4 to both sides of the equation. Because it's an equation, whatever you do to one side, you do to the other. Everybody with me so far? Okay. This should factor into a perfect square. you know, if you need to make your two separate parentheses, you can do that. What numbers multiply to positive 4 and add to negative 4? Negative 2 and negative 2. Better way of writing it is just saying x minus 2 squared. It will always come out to be two identical parentheses. You can always just write it as that squared. You know, just a hint, that negative 2, that's what we got when we did the middle term divided by 2. Right, over here, 14 plus 4 is 18. Now this is a problem like we saw yesterday. How do you get rid of the square? Square root. Anytime you add a square root, you do plus and minus. So we get x minus 2 equals plus and minus. How would I break down 18? Good. Final step. So we get 2 plus or minus 3 radical 2. Okay, so we didn't try it at the beginning, but if you had tried box method at the beginning, are there any numbers that multiply to negative 14 and add to negative 4? No. Completing the square will work on any quadratic. Ideally, if it can be factored by box method, you do box method because it's going to be faster. But if not, we make something that we can easily factor, and then we solve from there. Yes?
I get confused on the part where you put the plus 4 and then you got the x minus 2.
Okay. So essentially what I did is just factor this. So like yesterday, if I gave you that quadratic and I told you to factor it, you're saying, okay, it's a 1x squared, so I can do 2 parentheses. X squared breaks into x. What multiplies to positive 4 and adds to negative 4? Negative 2 and negative 2. I wrote it as the x minus 2 squared so that I could just add a square root to each side and cancel it. Other questions? So, first step, if you tried box method, are there any numbers that multiply to negative 2 and add to negative 3? No. So box method is not an option. That tells me I have to try something different. So if I did completing the square, first step you have to have a 1x squared. And we do. So we get to go to step 2. What's step 2 say? Okay, so I'm going to add my 2 over, so my constant is over here by itself. Now we have to make a perfect square. How did we do that? Half of the middle term, so half of negative 3 squared. Right. You can't, negative 3 divided by 2, that's going to be a decimal. I'm just going to keep it in fraction form. You could write it however you prefer. Negative 3 times, or negative 3 squared would be 9. 2 squared is 4. That's 9 over 4. If you add it to one side, you add it to the other. Alright. We have just created a perfect square. Now, albeit it's a little bit uglier than the ones we're used to because it has a fraction in it, we know it's a perfect square, so it's going to factor into something squared. And it's pretty much the same every time. X squared will break into x. If you want to find what's left, look, when you divided by 2, we had negative 3 over 2 before we squared. So that's what's going to be here. X minus 3 over 2. Everybody understanding how I got that negative 302? 2 plus 9 over 4 gives me 17 over 4. Okay, so we did step 3, we just did step 4 where we refactored. Last step is to solve. So to get rid of the square, you do your square root, plus and minus. I don't know the square root of 17, but the square root of 4 is 2. Final step to get x by itself would be to add our 3 over 2. These aren't like terms. 3 and radical 17, you can't combine them, so there's really nothing else you could do. You can write your answer like this. The other option would be, if you wanted, you could make them into a single fraction. You do not have to. These answers are equivalent, so either one is fine. Okay. Can I do today's problem? Step 2, move the constant, so I'm going to add over my 6. Third step, you take the coefficient of x, which was positive 11, divided by 2, squared. So 11 divided by 2, I can't really reduce that. If you square it, that's 121 over 4. You're welcome to put decimals, I just prefer fractions. This is going to factor into something squared. So it's going to be x, and it's always just going to be what that was when you divided by 2. So it was just positive 11 over 2. Okay, 6 plus 121 over 4, 45 over 4. Okay, next step, square root. With that, you always do your plus and minus. So I get x plus 11 over 2 equals plus or minus square root of 145. It breaks into 5 and 29, which is prime, so we can't break that down. Square root of 4 is 2. Final step, subtract the 11 over 2 over. And that would be your answer. Okay, how'd you do? We're going to keep working on this. This is all we're doing today. So let's look at one where the coefficient isn't a 1. So where it doesn't start out, it's just plain x. So look at that step 1 that we wrote down earlier. What does it tell you to do? Divide. We have to have a positive 1x squared. So since I have 9, I'm going to divide everything by 9. So I get x squared minus 12 over 9, 4 over 3, 0 divided by 9. Next step. Subtract over 1. Okay. Middle term, negative 4/3 divided by 2 squared. 4/3 divided by 2 is negative 2/3. When you square that, you get negative 2 squared is 4, 3 squared is 9. So we're adding 4/9 to each side. Everybody with me there? So now we can factor. This is a perfect square, we made it. So it's going to be x. What goes in here with my x? Negative 2/3. Negative 1 plus 4/9 is negative 5/9. Okay. Square root plus and minus. What's the square root of negative 5?
Will it be a 5?
Yep. I radical 5, and the square root of 9 is 3. So my answer is, if you add that 2/3 over, 2/3 plus and minus I radical 5 over 3. Let's go through one more with coefficient together, and then I'm going to give you guys one to try like that. Are there any questions on this? So, first step, what do we have to do? Divide by negative. So that gives me x squared minus 2x. My constant is already on the side by itself. That's just negative 7/4. So we had to do step 1, but we could skip step 2 here because the constant's by itself. Okay, now we need to take the middle term, so that's negative 2, divide it by 2, and square it. Negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. So you add 1 to each side. Okay, so this would factor into x. It was a minus 1 after we divided by 2. Negative 7/4 plus 1 is negative 3/4. Square root plus and minus x minus 1 equals plus or minus the square root of negative 3, square root of 4, 2. Final step, add 1 over, so you get 1 plus or minus I radical 3 over 2. Step is not a 1x squared, so we have to divide by 3. So we get x squared plus 5/3 x plus 1/3 equals 0. Second step, move your constant to the other side. third step, you take the middle term, so my 5/3, divided by 2, and square it. 5/3 divided by 2 is 5/6, so when you square, you get 25/36. Now we can factor. So then go to something squared, so we had an x, when you divided by 2, it was 5/6, so plus 5/6 squared. Over here, -1/3 plus 25/36, what do you get? Thir 13/36.
Oh yeah, it's 13/36.
Okay. Square root, plus and minus, so x plus 5/6 equals plus or minus square root of 13 over square root of 36 is 6. Final step, bring over your 5/6. Okay, our final. Question. There is a very short Math Excel assignment that is due tomorrow.